Hello, I am Sir Von, and in this video lesson log number 2, I will be presenting the second installment of the presentation that I prepared for adding vectors. The first presentation that I did for adding vectors is adding vectors graphically. And for this second video lesson log, I have prepared a presentation for adding vectors analytically, or that is adding vectors through component methods. Let me now share my screen. Before I proceed with my presentation, don't forget to like, subscribe, and hit that notification button. So in this presentation, you will be learning about analytical method of adding vectors. In the presentation that I have prepared, I have only limited the presentation to adding vectors in 2 dimensions, and I will only be showcasing an example that adds 2 vectors. In adding vectors analytically, it's important for us to know some basic concepts before we proceed. And the basic concepts that we shall be learning in this presentation are, number 1, basic recall of Pythagorean theorem, and the second one is a recall of fundamental trigonometric concepts such as sine, cosine, and tangent. We can begin our presentation or my presentation with the recall of Pythagorean theorem. In determining the sum of vectors, it's important for us to have in mind or to bear in mind first that we can express vectors in their components. When we say components, we can consider a particular example, say resultant force F sub r as shown in this graph. I've decided to also label the vector F sub r resultant force. Usually the term resultant is used to refer to the sum of 2 or more vectors. In this case, I've decided to use F sub r to label our first vector, the first vector that you'll see in this presentation. And going back to the concept of components, we can think of components as the magnitude of the vector force projected along a particular axis. Say the component that we are interested initially for this example is x component. We determine the x component by projecting our vector along the x-axis, and the length of this particular component represents the x component of our given vector. The y component is parallel to the y-axis, and that's analogous to what we have initially discussed about x component. And so if we talk about the components of a particular vector, we simply are concerned about how we can project that given vector along the given axis. And again, in this particular presentation, I've only limited discussing the 2 components, x and y. So what you'd see on the screen as an example showcases a vector that's projected along x and y axis. Now, the example that we have seen in the previous slide follows the relationship for Pythagorean theorem. This particular triangle is a right triangle, although it's not labeled. We note that with the Pythagorean theorem, we have the relationship c squared is equal to a squared plus b squared. We can draw a similar triangle to our example here, which showcases a triangle with the sides f sub r, y component, and x component. And the similar triangle that we can consider is labeled as C, A, and B. We note that C is analogous to F sub R. Both of them are referred to as the longest sides of the 2 triangles that you can see on the screen. And the two other sides, A and B, for this triangle, and y component and x component for this triangle are referred to as the shorter legs of our triangle. And we can now relate the three sides through the equation c squared is equal to a squared plus b squared. And in this case, we can think of the sides f sub r, f sub y, and f sub x, and relate the three sides following the Pythagorean relation and get f sub r squared is equal to f sub x squared plus f sub y squared. We can now consider a particular example wherein the components f sub x and f sub y are given. The value of f sub x, for example, is 4 newtons, and the value of f sub y is 3 newtons. We now can determine f sub r, or the magnitude of the resultant force. That means the length of this particular vector, using the Pythagorean relation. Substituting the values, we'll be able to get 5 newtons. We can verify the value of our resultant force by using a calculator. That is, we substitute the values. That's the square root of 4 squared plus 3 squared will give us 5 newtons. The second concept that we need to recall are basic concepts of trigonometry. Essentially, we are to review sine, cosine, and tangent of the given angle. Say the angle is labeled as theta. Let us now consider an example. Say the calculated magnitude in the previous example that I've given is 5 newtons. For this second example that we are to consider, we now use that magnitude 5 newtons to be the magnitude of our given resultant force. Now, other than giving the resultant force value, which is 5 newtons, I will also be giving the value of the angle, which is 36.87 degrees. Now, our task is for us to be able to know the values f sub y and f sub x. That is the component of the force vector, the given force vector f sub r, along y, that's f sub y, and along x, that's f sub x. Again, we imagine our similar triangle to reflect the letters A, B, C for a simpler illustration of the Pythagorean theorem. And following that triangle, we note of the relationship among the following: the angle theta and the y component. The angle theta is opposite to that of the y component of the given vector. Theta and the x component are adjacent. Theta is also adjacent to f sub r. However, f sub r is already labeled as the longest side or the hypotenuse. So whenever we refer to the adjacent side to the angle, we refer to the other side, not the hypotenuse. In our similar triangle here, we represent B to be the adjacent side to the angle theta. Again, it's not C because C is labeled as the hypotenuse, although C is also the A side that is adjacent to the angle theta. A is opposite that of the angle theta. As you can see, that's opposite. So A is labeled as the opposite side to the angle. And now we go back to the basic mnemonic device that we use for us to be able to memorize the relationship among the those that I mentioned earlier. That is the angle theta with the side opposite, which is the y component, angle theta with the x component that's adjacent, and the relationship between that of the opposite side, the y component, and the x component, which essentially will give us the trigonometric function tangent. So this SOHCAHTOA mnemonic device that we have here stands for sine theta is equal to opposite side over the hypotenuse, which is the longest side. In our similar triangle here, opposite side is A. That is, opposite to the angle theta is A. And the hypotenuse is C. That is, the longest side is C. We look at our given example here. Angle theta is opposite the y component. So we can replace our A here by f sub y. And the hypotenuse is f sub r. So we can write here f sub r. Now we proceed with ka. And ka means cosine of the angle theta is adjacent side over hypotenuse. Again, in our smaller triangle here, the adjacent side is B. That's why we see here B. And the hypotenuse is C. And finally, we have TOA. TOA means tangent of the angle theta is equal to opposite side over adjacent side. The opposite side to angle theta in our small triangle here is A. That's why we have A here. And the adjacent side is B. That's why we have B here. So that's it. That's basic recall of our trigonometry. And those are trigonometric functions, sine, cosine, and tangent. Now we can apply our sine, cosine, and tangent, or that is, we can just discuss sine and cosine for the meantime, to the given value that we have, or the given values that we have. The magnitude value is 5 newtons and the angle theta value is 36.87 degrees, and calculate for the components. So first, we can determine the value of the x component, that is f sub x, by using the relationship between that angle theta and the x component. The relationship is that the angle theta is adjacent that of f sub x. Since it's adjacent, we recall our mnemonic device, SOHCAHTOA here. That's ka. That is, we use the trigonometric function cosine. And following cosine theta equation, we have ka. The adjacent side is f sub x. Let's look at that again here. That's the adjacent side. And the hypotenuse is the magnitude of the resultant force, which is f sub r. We can compute f sub x by multiplying both sides with f sub r. So we can compute f sub x equals f sub r cosine theta. Now we can determine the second component. The second component is y component. That's f sub y. And from this illustration, we note that f sub y is opposite that of the given angle. The given angle, once again, is 36.87 degrees. And use the trigonometric function, again, that's side opposite. So that's so. And so we use sine. And sine of the angle theta is equal to opposite divided by the hypotenuse. Substituting the labels that we have for the opposite side once again is f sub y, and the resultant force magnitude f sub r is the hypotenuse. We can compute for f sub y by multiplying both sides with f sub r. So we get f sub y equals f sub r sine theta. And that's what we have here in this equation. F sub y equals f sub r sine theta. We now can substitute the values and calculate for the components f sub y and f sub x. F sub y is 5 newtons times sine of the given angle, 36.87 degrees. So we get 3 newtons. And we can calculate for f sub x. F sub r, that's 5 newtons. That's the magnitude of the resultant force, times cosine of the given angle, 36.87 0.87 degrees, that's 4 newtons. And we showcase how it's calculated in the screenshots of the calculator. That's 3, and that's 3.99, rounded off, the value is 4 newtons. Well, so far, we have already reviewed basic concepts that are essential for us to add vectors analytically. And so we now are ready to consider a particular example. And this example now is the main topic, the most important concepts that we need to know in this particular presentation. So we now can consider a set of two vectors, and the task is for us to add the vectors using the method, analytical method or component methods. In adding vectors analytically, the first step that we need to take note is to consider the given direction, whether the direction given are expressed in pure angles for easy calculation. So we note that the given directions are north and east. So f sub 1 is 20 newtons north, and f sub 2 is 30 newtons east. So our first task is to convert these angles, these directions rather, as angles. North, if we are to imagine our Cartesian plane, is 90 degrees, and east is 0 degrees. So we can express our given vector as, our given vectors rather, as 20 newtons 90 degrees. That is, we've converted north to be 90 degrees and east to be 0 degrees. Once again, our task is to add the given vectors f sub 1 and f sub 2 and determine the resultant force f sub r. We take note once again that in adding vectors, we need to compute both the magnitude and the direction of the vector. And in this case, we can express the direction as either a pure angle or with cardinal directions north, east, south, and west. We have already expressed our given vector in pure angle. So we can now use our original equations for vector components with cosine and sine. There. For our given vector f sub 1, we compute for the components f sub 1x and f sub 1y. For f sub 1x, again, our equation for x component is we multiply the magnitude of the given vector to the cosine of the angle, and the angle is 90 degrees. So that's cosine 90 times 20 newtons is 0. And f sub 1 times sine theta for the y component. Again, we recall that in order for us to compute for the y component, we need to multiply the magnitude of the given vector with that of sine of the angle theta. And again, the angle theta is 90 degrees. So that sine 90 is 1 times 20 newtons is 20 newtons. We do the same with f sub 2. Substituting the values, we get 30 newtons times cosine 0. Cosine 0 is 1. 1 times 30 is 30. That's why we get 30 newtons here. And we do the same for f sub 1 y. That is the y component. Oh, sorry, this should be 2. F sub 2 y. Can quickly have that edited. This is f sub 2y. There. And yeah, we substitute the magnitude of f sub 2, which is 30 newtons, and multiply that with the sine of the angle theta. That's sine 0 is 0. 0 times 30 newtons is 0. The next step in this calculation is to get the sum of each of the components x and y. So the components f sub 1x and f sub 2x will add up to 30 newtons. So the symbol sigma here represents summation of the forces along x for f sub x, and sigma here again, is summation of the forces along y. That's F sub y. 20 plus 0 is 20 newtons. We now are able to calculate for the summation of the components, and we are now left with the components x and y for our given vector, for our given vectors. We then are ready to calculate for the magnitude and the direction of the resultant vector that we want to compute. Following Pythagorean theorem, we can substitute the values of x and the y component in our equation, which was initially introduced as part of the recall of the basics. We substitute 30 newtons for x component, for the x component of our resultant force, and the y component, which is 20 newtons, and get 36.06 newtons. We can verify the value by using our calculator, and that is the square root of 30 squared plus 20 squared equals 10 square root of 13. And we can convert 10 square root of 13 to decimal by pressing this function, which converts that expression to 36.0555, or that's 36.06 newtons. We have calculated the magnitude of the vector. We now are ready to compute for the angle, the pure angle that is. In order for us to better imagine our vector, I have it illustrated. And in this illustration, we note that we are to compute for the angle theta. We have already established that the y component is 20 newtons. So this is already drawn to scale. This is 30 newtons, or at least approximately. And from this illustration, we can guess that the angle is between 0 to 45 degrees. In order for us to compute for the angle theta, we use the trigonometric function tangent. And the reason why we use tangent is that it follows what we are given or what we have calculated so far. We've calculated for the y component, we've calculated for the x component, and those two are related to the angle theta such that theta is opposite y component and theta is adjacent to that of the x component. We now can substitute the values 20 and 30 newtons to our expression. Opposite side, that's f sub y, is 20 newtons. And adjacent side is f sub x, or that is, these are summation values already, summation of f sub x and summation of f sub y. And that's 30 newtons. For us to get the angle, we need to introduce the inverse tangent and get 33.69 degrees. Here's a screenshot of how it's done in the calculator. Or we can quickly do that in our calculator here. In order for us to get the second function, tan negative 1 here, we need to press shift and the tan function, and tada, we'd be able to use the inverse tan function and fraction function here and substitute the values 20 over 30. Close parentheses, we'll get 33.69 degrees. The value that we calculated is a pure angle, that's 33.69 degrees. That we'll actually do already. So far we have the magnitude, we calculated the magnitude already and the angle, and that already is our vector. But we can add the cardinal direction north of east, as illustrated by this arrow here, as another expression of the angle of the vector that we are looking for, that is the resultant vector that we're looking for. Or we can also express the resultant vector using the direction uh, east of north, which is essentially uh, the complement of the given angle, 33.69 degrees. So that's 90 minus 33.69. That's around 50, 56, around 56 degrees, 56 point something degrees. So we can now combine the magnitude and the options that we have for direction. That is, we can have pure angle, 33.69 degrees, or we can have it expressed with cardinal direction north of east, or its complement, that's east of north, but that's around 56 degrees. So finally, I've chosen north of east as the direction with the value 33.69 degrees to couple it with the magnitude of the resultant force, which we have calculated initially, and that is 36.606 rather, 06 newtons. So finally, the answer is the resultant force is 36.06 newtons, 33.69 degrees north of east. And that's it. We've already calculated through analytical method or vector components the two given vectors that we have. As summary, in this presentation, we were able to recall basic concepts, Pythagorean theorem and trigonometry, essentially the basics of sine, cosine, and tangent, in order for us to be able to use those concepts in adding vectors analytically. The steps that we follow in analytical method are, number one, we first determine the components of the given vectors. In the example that I've shown, we were able to calculate for the components of the two vectors that we have. And then we sum up. That is, we recall the summation symbol that we use. That is, we simply add the components for us to be able to determine two summation components. Summation of the components. Summation along x and summation along y. The next that we did is to calculate for the magnitude and the direction. First, when we calculated for the magnitude, we applied the Pythagorean theorem, which again uses the basic relation c squared is equal to a squared plus b squared. And then finally, we use the trigonometric function tangent to compute for the angle. And that's it. Thank you.